number 8, a square pyramid, base 30 mm, axis length 50 mm, lying on VP with one of its triangular face on VP. Its axis is parallel to the projection of the pyramid. Let's start with a reference line XY. Given the solid is lying on VP, solid is a square pyramid, so we have to start the front view first. It's given one of its triangular face on VP. So whenever we have triangular face on VP, we should draw the front view in side position. Let's say we have 30 mm base side, so that base side is kept perpendicular to XY. This base side is kept perpendicular to XY. So that is the rule for side position. So we join this square in side position. So we have 15, then 30 mm. So this can be further given by a vertical line. Once again, we can just complete this. We will get a square of 30 mm. So this can be extended, and we can just give the dimension here also. Here itself we can add the dimension. So the base side taken is 30 mm. So this is 30 mm. We have A dash, B dash, C dash and D dash. Because it is a pyramid, we need to join the corners as well. So we join the corners and we get the diagonals. The intersection gives us the vertex. So we get this diagonals crossed. So finally we get the intersection O dash. So now from this we can draw the top view. Because it is resting on VP, the 4 points should lie on the XY line in the top view. All the 4 points A, B, C, D should lie on the XY line in the top view. So when we just see from here, D is visible, A is not visible, C is visible, D is not visible. So therefore we put D and A within bracket, B and C within bracket. We put D within bracket and C a visible point. So therefore it's C within bracket B. Now that the pyramid is of 50 mm height, so therefore we take 50 mm here. We take 50 mm. So that's 1, 2, 3, 4, 5. So we get the point O. So now we can join this. Can join all these 3 points so that we get the isosceles triangle. Initial position of any projection of solid problem is very crucial. So we should take utmost care in giving the correct initial position of any projection of solid problem. Here is the front view first. We have drawn the front view first mainly because the problem says the triangular face is on VP. So when a solid is on VP, we have to draw the front view first. So here is the top view. We can put the axis line also. We can put the axis line also. So this is the initial position of the square pyramid with one of its triangular face completely on VP. Now that we have the entire base completely on VP, we are in the second stage we are going to make one triangular face on the VP. So now what we have to do, we have to take one slant edge. You have to take one slant edge along with vertex, it becomes a triangular face. So therefore we take the triangular face here. The triangular face that we take is BCO. So we get BCO, B1 bracket C1 and O1. Afterwards, with the help of this line, we are going to redraw the entire triangular face so that we are going to redraw the entire diagram so that one triangular face is completely lying on VP. The top view of the triangular face is touching on XY line. So what do? We take this and we just find out an arc through this, and when we take the across the flat distance, and if we cut it through this end, we will be able to redraw the triangular face. So we just get the triangular shape. This is the final top view for a square pyramid with its one triangular face on VP. So we have the final top view. So we can take the midpoint also, so that we can just redraw the axis here. Here is the midpoint. So through this point we can complete the axis of the square pyramid. In the problem it is given that the axis is parallel to HP. So therefore we need to get true length of the axis in the top view. So we are getting the exact true length, that is 50 mm in the top view. Now that we have to name this. This is A1 bracket D1. Now we can project this and get the final front view. Let's say we draw one line through this and another line through this, one more line through O. Just to see the visibility of the object, we just assume one arrowhead downward. We assume one arrowhead downward. We go to the extreme edges. This is left extreme edge, this is right extreme edge. We assume one horizontal line on both the corners. Whatever is below this is completely visible. So this is a visible zone. This is a visible zone. Except OC and OB. OC and OB, they are invisible. Except OC and OB, everything lies within this visible region. So we erase this. This is not part of the answer. So we erase this. Now we understand the visibility, how to check the visibility. Only OC and OB are invisible. Now we project the horizontal lines from points A and B to this end, and similarly for C and D till this end, then O till the projected O line. Yes, so we will be getting the points O1, A horizontal combined with A vertical gives A1 dash, B horizontal and B vertical gives B1 dash. Similarly, C horizontal and C vertical gives C1 dash, D vertical and D horizontal gives D1 dash. So finally we join all these points. So as far as outer edges are concerned, they are strictly visible. So we blindly connect the outer edge first. We connect the outer edges. They are visible edges. So it's O and A. OA is again an outer edge, visible. Similarly, BC is an outer edge, visible. BC is an outer edge, strictly visible. Similarly, we have CD is again an outer edge, so therefore it has to be visible. OD is outer edge, is also visible. OD is also visible. OD is also visible. Here ABCD is completely visible, so therefore we can make this dark. We know only OC and OB invisible, so we put OC and OB as dotted. We put OC and OB as dotted line. OC and OB as dotted line. Here again we can apply another simple logic. The base is completely visible. Suppose base is completely visible, then any one of the face may be invisible. Here we have the ABCD is the base which is completely visible. That is why we are getting OCD invisible and OAB invisible. So when the base is completely visible, few of the faces may go invisible. That is the logic. So now to complete that, we need to draw the axis line dark. So make the axis dark. The axis line. So we just go through and verify the conditions given in our problem. So we need to just put the axis height also. Given the axis height is 50 mm. So draw one horizontal through this vertex. Try to extend this extension line here also. With the help of small arrows, we can just introduce the exact height, that is 50 mm. So now square pyramid, base 30 mm, yes, base 30 mm, length 50 mm, length 50 mm given, lying on VP, yes, it is now completely lying on VP. But here you have only one triangular face, that is totally 3 points are on XY line in the top view. So therefore one of its triangular faces on VP. Again axis is parallel to HP. Yes, axis in HP, axis gives true length. So therefore it is strictly parallel. But in VP it is inclined. So you are getting a reduced length in the axis. So this is the complete answer for the given problem.